Welcome to data analysis with Python. Finally, we're on with Capstone project, and I'll be taking like five or six of this. So, in this video, I'll be taking the first one, which is something about personal knowledge tracker. So here, this project analyzes and visualizes personal learning data to uncover insights about time management, engagement, difficulty levels, and burnout risk across various knowledge categories. So it tries to portray someone trying to upskill or trying to learn a new skill or trying to develop uh, themselves personally. Okay. So, and the data set I'm using, let me quickly show that. Personal knowledge tracker right here. Okay, CSV file that is. So we have dates. So this person has tracked their activities for several days, and we have about I think 100 data points. Like this is totally made up. Like it's made up just for the sake of education. Okay, so starting from I mean, the data are all over the place, right? Like, right? We can rearrange this according to the day and things like according to date, right? If we want, but it's all in 2025. So, so we have all of this. We have date, topic, the category of the topic, like technical writing is under soft skills, network is in under soft skills, meditation techniques is under wellness, CI/CD pipeline, that's DevOps, time management under wellness, data visualization is under data science, and so on and so forth. Then the time spent on each of these activities and the difficulty level from 1 to 5, the engagement level from 1 to 5, the burnout risk is it low, medium, or high. Then we also have notes like the specific activities carried out on that. That's the kind of thing we are looking at. So first of all, let's look at the data. Of course, we've seen that in the original in the CSV file. Now let's make that into a data frame. So load and inspect the data. Of course, to do this, we need pandas. So we import pandas as PD and we load the data into a data frame. So by calling the variable name df equals pandas.read underscore cv personal knowledge tracker. That's the name of the file. And then we view the first 50 of that. So this is what we are working with now. So I run this and then it takes a bit of time and then we have this out like this. So or should they come up here? All right, so we have all those things. So we have the dates, we have everything like we've seen up there. So, I mean, if I remove the head 50, then we can know the dimension of the data set. So it's 200 rows and 8 columns. So we have 200 data points with 8 columns that we can work with. So of course, here we are loading and inspecting the data set. So that includes exploratory data analysis. So I just run df.info for exploratory data analysis. So here we have, like we've seen already, 200 entries numbered from 0 to 199, and then 8 columns: date, which is object; topic, which is object; category, which is object; time spent is float; difficulty level is integer; engagement is also integer. That's more, we can also more or less make those into object if we want. Then the burnout risk and notes are also objects. So you can carry out calculations with time spent and things like that, and you can categorize the rest. Then talking about description now to describe, so this is about numerical stuff, right? So time spent, so the minimum time spent on anything is 0.5 hours. That's like 30 minutes. And the maximum is 4.5 hours. That's like 4 hours, 30 minutes. So the average time spent on any course, on any of those activities is 2.63. And then, of course, the difficulty and engagement levels are more or less categorical, but I mean, we still have, because they come off there as integers, that's why we have all of this. Okay, so obviously the simplest level of difficulty and lowest level of engagement is 1, and the maximum for each is 5. So let's clean data and pre-process. So the key thing we are doing here is to want to convert dates and ensure numeric types, and encode categorical data like burnout risk. So here we want to convert dates to column date column to date time, which is very good for analysis, right? So we have df date column. So we call it to underscore date time function inside pandas that helps us to convert whatever date format we have there into date time, which is good for analysis. And then another thing we are doing is we are checking for missing values. If there are missing values, then we can probably drop some or replace them or something. And then another thing we are doing is we are doing some kind of feature engineering. So by binning by encoding the level of burnout. So we just say the burnout risk encoded is a new column, and then so that is based on the burnout risk. So we map that with the burnout map. So low is 1, medium is 2, high is 3. This is particularly good if you're doing some kind of machine learning thing. So with this now, see what we have. So for all the columns, no data is missing. So we are good to go. So we don't have to worry about dropping or imputing something. Then for the rest now, you can see we have a new column, which is burnout risk encoded. So low is 1, medium is 2, and high is 3. So that's what has been done to that now. So the next thing we want to do is we want to start taking those things. Now, I mean, if you have a data like this to work with, so you know you have to you do the calculations, you also do the visualization, and of course you tell the story, right? So what you may have to do if you have a capstone project, maybe more elaborate than what I'm doing here, but this is basically this skeleton, this structure of what might be expected to do. Then if in some cases you may be asked some specific questions to unravel based on the data set you're working with. So here we want to visualize the time spent by category, right? So objective, identify which categories consume most of your learning time. So here now we are using, so it means we want to it's category time, then we want to group the data frame by category, and the sum of hours spent sort in order, like sort, you want to sort the sum, like when you add up all the time spent on the, maybe on maths, on data science, on data visualization and things like that, you want to see which one takes the most of your time. So that is what is happening here. So we group by category and sum of the time spent on each category in that case, and then want to visualize in a plot. You want to use a horizontal bar chart to get that going. So I run this now, and then this is what we have. So here, you see, soft skills take the largest share of time, followed by mathematics, followed by DevOps, followed by data science, AI stroke machine learning, followed by wellness, data engineering, and programming. So from the insight we have here, okay, I mean, what we did up there is to identify which categories consume most of your learning time, right? So now we see from here, obviously, that soft skills take the most time, programming takes the least time. And does this match with your goals, or you need to switch things up together? Now, basically here, uh, now when you do all this, it should actually make you curious, like why should soft skills take the most time? And again, if we go back and we try to look at the soft skills, there are things like technical writing, networking, yeah, public speaking. So those things they may look very easy, right? But a lot of people who are very talented, who are very good coders and programmers, they find it difficult networking, they find it difficult writing and things like that. Maybe that's why that may be taking so much time, as we see here. Then we say programming takes the least time. I mean, for this person, programming comes very easily to them, right? Like just know the rules and regulation, just know the syntax, and then follow it up. But then for the soft skills, it takes a lot of time. So we can see that here already. Now the question is, does this match with your goals, or you need to switch things up to get to achieve your goals, right? So I mean, if this person is someone who has already mastered some of these soft skills, so they may want to reconsider that. Oh, okay, maybe they will need to give more time to programming, and not so much time to soft skills. So, but I mean, this gives a clear picture of what has happened, and this can actually inform what the person should do in the next in the coming days, right, to improve things. Right. Okay. So next, we want to look at difficulty versus engagement heat map. So based on the level of difficulty, what level of engagement is this person putting up? So we want to see if high difficulty topics also have high or low engagement, right? So here we are using a pivot table. Um, so we want to create a pivot table that groups the time spent together, and we index with the difficulty, and then in the values on the face will be the counts of all the counts across difficulty and engagement, right? So with this now, see, okay, this is done, right? So I just go next, and now this. Okay. So see what we have here now. So we are making a heat map based on the aggregate time spent, based on difficulty level 1 to 5 and engagement level 1 to 5. And you can see this, I mean, the highest uh, sessions count is 14, so there are 14 sessions for engagement level 4 and difficulty level 5. Okay, so we see that here. So skills with difficulty level 5 and engagement level 4 have the highest session count of 14. So maybe that makes sense, right? Like it, there are difficult things, and then the engagement level is 4, and then so the person gives so much time to that. So of course you tend to give so much more time to something that is not so easy for you to do, even like a student, right? If a course comes easily to you, of course it's not like you won't read it, but while you are assigning 1 hour to that, you may take 3 hours or 4 hours on a course that is really troublesome, right? Then we also see that skills with difficulty level 2 and engagement levels 4 and 5. So you can see engagement levels 4 and 5 here, and difficulty level 2 both take 4 sessions. I mean, for obvious reason. Now the question is, do this make sense? Yeah, I've tried to make sense of it. Like if something requires, it's not so difficult to grasp. You don't have to spend so much time trying to learn it, basically. Then we also have the burnout risk trend over time. So the objective here is to track how burnout risk changes across learning sessions. Okay, so we want to get across the sessions. So here we are doing a line plot to see how the burnout risks go, and we sort according to time. So it's a kind of time series to help us know how the burnout risk changes across learning sessions. So I run this now, and then it gives us this kind of time series thing. And then you can see there are bursts of burnout. Burnout level 3 is dangerous, right? 2 is medium, 1 is the lowest, right? So you have some subjects that are pretty easy to go with, and then some are medium level. Thankfully, the burnout ones are not as many as the rest, but I mean they should also be paid attention to. So the insight we see there is that there are periodic high and low burnout risks, as you can see at this peaks at 3. All right. And the question is, can something be done to even things out? Like, is it that do you want to break the sessions down instead of having to give so much time to it at once? Do you want to learn in smaller bits, or based on some further digging, you might know what to do with that. So the next is average time, difficulty, and engagement by category. So what is the average time? You want to understand which areas are most demanding or engaging, right? So in this case now, you want to aggregate the metrics. You are grouping the data frame by category, and then time spent in hours, and the difficulty based on 1 to 5, and as well as the engagement. So you want to take the average of all of these things, and then you want to do all of that. The metrics now, you want to make a bar plot of that to see which is taking which areas are most demanding or engaging. Okay, so we have this kind of plot now. So AI stroke machine learning, data engineering, data science, development, DevOps, mathematics, programming, soft skills, and wellness. You see them like that. Now, by the way, this right here, this is the tallest as far as difficulty is concerned for soft skills, as you had seen in the data before. So the insight we draw from here is that most of the time spent was spent on soft skills. So you can see time spent in hours. So the tallest of the bars for time is with soft skills. So most time is spent on soft skills. Then soft skills also have the highest difficulty level. Maybe that makes sense that because soft skills have the highest difficulty level, most of the time spent on it Most of the time is spent on it. Then the other thing is that data science has the highest engagement level. So when you talk about engagement level, the green bar, so data science has the highest engagement level, maybe because it is interesting or data issues are really important across board. Probably that might be a motivation for that. Then the question is, what do you have control over? Is it the time spent or the engagement? Well, it seems it will seem to me that you have control over the time spent and engagement. And just like I said before, if you don't have so much problem with soft skills, you may want to cut down the time you spend on soft skills. And talking about engagement too, yes, you know, time spent and soft and engagement, they kind of have they kind of correlate, so to speak. Also, I think so I may want to test that out, if that's really interesting to me. So how can you make the most of the things under your control? So if you really don't have so much problem with soft skills, you may want to, spread the time to other areas, like maybe to wellness. Like maybe you have been paying attention to every other thing without paying attention to wellness that much. So so it all depends on your peculiar situation. So another thing is you want to display notes for high difficulty or burnout. So the notes are the specific actions taken under each task. So you want to review qualitative notes to improve future study plans. So here we want to filter for difficulty or high burnout. So high difficulty, so you have the data frame, uh, extracting the difficulty column to see if it is greater than or equal to 4. That's high difficulty. But if it is not, so you want to see if high burnout is just equal to high, and then you have the result there. So now you want to print notes for high difficulty sessions. Then that'll be high difficulty date, topic, and notes based on that. Um, okay, I guess I have a bit of issue with this. So let me just come. Yeah. Okay. So see, the code is here, and then so these are notes for high difficulty sessions for networking, right? Walked through exercises. So the last time you tried it, was it effective? You may want to review that. Another in March 25, you walked through exercises. 21st of June, you built a mini project around networking. Then 16th of February, that was before that, you walked through exercises and all that. So you want to see, should you do more of walking through exercises um or trying to build a mini project around networking and all that. So in fact, let me just add dot head, then 50 to so we can have a kind of continuum more. Okay, yeah. So took detailed notes for CI/CD pipelines, time management, and things like this. So you have all that. So for high burnout activities, also you want to see, okay, CI/CD pipelines. You took detailed notes. Were you too finicky about taking the notes? That you may want to examine that. Like, was it really necessary taking that much note because it's a high burnout risk session? Do you have to take less? Would less note be fine? Especially if you really don't need it. So you may want to review all of these things. Then, of course, for deep learning, you completed the tutorial. Instead of completing the tutorial, is it better to rather do something hands-on? So for calculus, you wrote a blog post. Do you understand calculus that much to want to write a blog post? Since it's a high burnout risk thing, so do you have to write a blog post, or is it just fine that you just solve some problems? It all depends on your peculiar situation. So the insight here is that what can you do better to minimize difficulty and burnout? That's like the kind of questions I've been answering before just now. Okay. So let's talk about time spent versus burnout risk. So do you want to compare the time you spend versus the risk of burnout of the activity? So spending more time in a session may correlate with higher burnout risk. Of course, that goes without saying, right? But of course, that may not always be true because one of the things you also want to do as a data analyst is to pay attention to curious things. Some things may go against intuition, and then you may want to find out why that is the case, or maybe there's a problem, there's a mistake somewhere. So it's all about curiosity. You want to find out uh, why things are working the way they are working, right? So time spent versus burnout risk, right? So see all this now. So the burnout for high burnout risk, you can see the time spent is about something close to 3 hours, medium, and then for medium, burnout risk it's about 2.5. For low burnout risk, it's about 2.75. Now, I think it makes sense if you spend this much time on low burnout, on task with low burnout risk. And for medium, maybe you may want to consider spending more time, or maybe it's just fine like this. So, I mean, I would then when you come to the high burnout risk, maybe because it's really important, you may want to allot so much time to it. But if you don't, if you can do make do with less time, you may also want to consider that. So high burnout sessions tend to have longer study durations because maybe in the first place because you're not so very good with that aspect, and you need to spend more time with it. So but of course, you may also want to consider capping your sessions at a sustainable duration. Sometimes I want to do some coding and then I feel I'm not in a better frame of a good frame of mind. I mean, we just want to cut it short, I mean, go to bed and then wake up fresh to take it up. So it all depends on who we're talking about here. So topic popularity and repetition. Okay. Now, because some topics are popular, maybe you really want to, maybe they just pique your interest, right? So we want to examine that to see which topics recur, indicating focus areas or potential knowledge gaps. So probably you have knowledge gaps, or maybe you are doing a course in data science. So you want to really give it more time and all that. So that's what this is about. So here we are counting the topics and we are looking at the value of the counts, right? And then based on that, we'll plot a bar graph to see what that looks like. Okay, so from here, we see that for this public speaking takes 15 sessions, data visualization takes something close to 15 also, and Python programming takes the least of the sessions, right? So we see that public speaking is a deal. I mean, for among tech people, right, public speaking may be really necessary because most of the times tech people just they are stuck with their computers. They have not so much skills when it comes to speaking in the public. And then you have data visualization following that, and deep learning, meditation techniques, and so on and so forth. So based on this data we have, this is what it is. So the question is this trend okay? Like if this is a data speaking about you, is this trend okay? It's speaking about a group of students in a class. So would this be a good trend, or attention should be shifted to other areas? Or maybe they are taking Python programming for granted as if it's some simple stuff, or maybe because of the use of AI, probably that's really easier. So those can be different things. So if the trend is okay, then we can work with that, or should it be adjusted for some reason, whatever reason that may be? Like, is it that big? Probably, if somebody is being scored across these things, for instance, if the person gets like a very low score in abstract algebra, so they may need to increase the number of sessions for that, right, to make up for the time, right? And if everything is fine the way it is, good, then we can leave it that way. Then let's talk about category-wise burnout risk. So if you look at the categories, there are categories and there are specific activities, right? So if you look at the categories, which one has the highest potential for burnout? So some categories might be emotionally taxing, consider rotating them with lighter ones, right? So that's one insight we can draw. But let's run this first. You're also doing a bar, grouping by category and the average burnout risk and the encoded burnout risk, right? So we have something like this. So wellness, maybe things like meditation and all of that has uh, the highest possibility for burnout. So you may want to spend less time on that, or if it is worth it, then you can keep it the way it is. AI, artificial intelligence and machine learning has the lowest. So if it works, then you can leave that alone. So, um, or you may also want to consider, okay, maybe because based on your schedule, you can make sure that you do you can take care of a category with higher burnout risk and then move on to something easier to ease the tension, right? Then lastly, let's talk about most efficient sessions, and the index for knowing the most efficient is high engagement and low difficulty. So these are low friction, high reward learning activities. So you want to consider repeating or expanding on them, right? So for efficient sessions now, we take engagement greater than or equal to 4 and difficulty less than or equal to 2. So that's our index for engagement. And then we print efficient, high engagement, low difficulty sessions. And then we have the efficient sessions. We just extract the date, topic, category, and notes, and this is what we have right here. So these are like the top the most efficient sessions, right? So machine learning is quite efficient. If you've been completing a tutorial because it's efficient, you may want to stick with that. Then abstract algebra in mathematics, you may want to it took detailed notes and that has been working well, so you can live with that. Then Git and GitHub under DevOps, you may want you explore related tools. You may want to keep doing that. Data visualization under data science, you had difficulty with one section. Then the next okay, in January, right? January 31st, walk through exercises. Then 11th May, you had difficulty with one section and all that. So, but I mean, it's all about overcoming challenges and working with things like this. So, with this, we come to the end of all this, right? So you can have many more questions. So one thing in particular is we also want to arrange this according to the dates, make it a time series so that it follows a particular order of dates, and then maybe that can also give some insights. Probably you need to switch up how you the order in which you attend to some of these things. So that is how this has been today. Really interesting. In the next video, I'll be talking about content consistency analyzer. So, for maybe for a content creator, you want to evaluate how you've been performing, how, and maybe a way to do better, right? So, that's how it's been. Let me know how helpful this video is for you. And if there's a kind of data you like me to work with, if you have a suggestion about a capstone project, I mean, make up data for that and try to, work around that and see. So you can draw so much insight depending on the question you are out to answer, right? So feel free to do that. And if you're subscribed, you are having a nice time already, I can imagine. If you have not subscribed, be sure to do that and hit the notification bell so you can always get alerted each time a new video is released. Be sure to like and share also so that more people can have access to this great content I have on here. Till I come your way again, keep doing data right. Bye.